Transmembrane transport. Today we are looking at the membrane transport across plasma membrane. The diffusion, the term means it's a passive movement of a solute across a permeable membrane. It depends upon a concentration gradient. A concentration gradient is present when a membrane separates two different concentrations of molecules. Substances diffuse according to their concentration gradient within a system. Different substances in the medium will diffuse at different rates according to their individual gradient. After a substance has diffused completely through space, removing its concentration gradient, molecules will still move around its space, but there will be no net movement of the number of molecules from one area to another. And that state is called as dynamic equilibrium. Several factors affect the rate of diffusion, such as the mass of the solute, the temperature of the environment, the solvent density, and the distance traveled. So, once again, diffusion means it is the movement of a substance according to its concentration gradient. And after it has diffused, there will be no net movement of the number of molecules from one area to another. That state is called as dynamic equilibrium. The factors affecting diffusion are mass of the solute, temperature of the environment, solvent density, and distance traveled. Such as an example for this in daily life is opening a perfume bottle. Once you open the perfume bottle, the smell will diffuse out from the bottle to the environment. This is how we observe the diffusion as a diagrammatic representation. From extracellular fluid which has large number of solutes. Solutes are these particles are solutes. So these solutes will move from a higher concentration gradient to its lower concentration gradient across a permeable membrane. Okay. So as time passes, the diffusion rate also is increased. After a particular period, there will be no net movement of the particles. There will be movement of particles, but there will be there is number of net movement from one area will decrease. Next is osmosis. You might be familiar with the term osmosis. It's a movement of the solvent particle from a range of its higher concentration to its lower concentration across a semi-permeable membrane. Now before that, what is a solute? Any substance that is dissolved in a liquid solvent to create a solution like NaCl. It is a solute dissolved in water. That is the solvent. Water is the solvent. NaCl is the solute. Semi-permeable membrane is any type of biological membrane that will allow certain molecules to pass through it by diffusion, and it occasionally by specialized diffusion. Osmosis occurs according to the concentration gradient of the water across the membrane, which is inversely proportional to the concentration of solutes. Osmosis occurs until the concentration gradient of water goes to zero, or until the hydrostatic pressure of water equals the osmotic pressure. Osmosis occurs when there is a concentration gradient of a solute within a solution, but the membrane does not allow diffusion of the solute. This is the picture of osmosis. You find the level of liquid in this first figure. It is equal. Solute is less here. Solute is more here. So water has a tendency to move from its higher concentration to its lower concentration through a semi-permeable membrane. So next, after a few seconds or minutes, you find